This video is about interfaces. Unlike C++, which allows multiple inheritance, that is, inheriting simultaneously from more than one class, Java only allows you to extend one single class in an inheritance hierarchy. Java achieves its own type of multiple inheritance through the keyword implements and class-like structures called interfaces. While you may only extend from one class, you may implement many interfaces in a class specification. In the code on the next slide, we will define a simple interface explodable. We will implement that interface in the class Klingon Bird of Prey that also extends from its parent class Starship. By extending from Starship, the class Klingon Bird of Prey inherits all of Starship's methods and data members. By implementing the interface explodable, the class Klingon Bird of Prey gains the ability to explode and disintegrate. The class must define these functions since it has implemented the explodable interface. If it does not do so, it will generate a syntax error when the class is compiled into bytecode. In this example code, first we define the interface explodable. And here we prototype two functions, explode and disintegrate. Therefore, if we implement this interface in any class, we must include both the methods explode and disintegrate, or if we were to try to compile the project and we did not, it would result in a syntax error. Then following below, we have a class Klingon Bird of Prey that extends or inherits from the class Starship, that is, it's its superclass or parent, and it implements explodable. And as required, we have to implement or include the functions explode and disintegrate. When creating swing and AWT applications, interfaces are implemented within a class to listen for and handle events. These events correspond to button clicks, key presses, mouse movement, and changes to components on a JFrame or JAPPLET. To listen for an event, you implement an interface, add an event listener that corresponds to that interface, and then code an event handler that relates to the listener. We can compare this to the way that C++ MSC applications listen for message IDs, and those messages are then mapped to a message handler function. When creating a class in Java, you can code a function as abstract. When you do this, you simply prototype it and you define it later in a subclass that extends or inherits from its parent object as a superclass. So for instance, if I had the function explode and I made it abstract in Starship, and then I were to have Klingon Bird of Prey or Galaxy class Starship inherit from that class as a parent, I would have to implement the method explode because it was abstract. Otherwise it would result in a syntax error. Well, for each interface that you implement, there are certain methods that are like abstract functions, meaning they must be included even if you don't use them. Implementing an interface without adding its required abstract methods results in a syntax error. To summarize, handling events in Java is usually a three-step process. First, you implement the required interface. Second, you add a listener to each component you wish to listen to. And third, you add an event handler method that responds to the event when it is detected. Do not confuse the concept of a graphical interface, that is the background of a JFrame or JApplet that we add components to or draw on, with the kind of programming interface we implement in a Java class to listen for and handle events. These are two completely different things that share the same name, and this can sometimes be confusing. Here's a list of some common Java interfaces and the events they listen for and handle. First, ActionListener listens for and handles button clicks. KeyListener listens for and handles key events. MouseListener listens for and handles mouse events. MouseMotionListener listens for and handles mouse drag and mouse move events. TextListener listens for and handles text changing events. ItemListener listens for and handles checkbox and listbox events. AdjustmentListener listens for and handles scrolling events. Runnable listens for and handles threads and run. WindowListener listens for and handles window events. FocusListener handles focus events. ComponentListener handles component events, and ContainerListener handles container events. Event handler interfaces derive from the Java AWT event package. Therefore, to implement these interfaces, you must include this package in your class. For example, I could code import Java AWT event and use the asterisk as a wildcard to grab the whole package. Now that we've covered the preliminaries, let's examine in more detail some of the interfaces we can implement to handle specific events and the event handler methods we must include in our classes when using them. Let's begin by examining one of the most commonly used event-based interfaces, which is ActionListener. ActionListener handles events such as button clicks in a JFrame or JApplet application. If you implement this interface, you must add an actionPerformed method that takes an action event as an argument. You must then call ActionListener this on each component you wish to listen to for events. To summarize, first, import the Java AWT event package. Second, implement the ActionListener interface in the class. Third, add the event handler method actionPerformed. And fourth, add ActionListener this on each component you wish to listen to. In this example, we're adding ActionListener, and this represents how you would do it if you were coding a project from scratch using a simple text editor. So we have two JLabels and three JButtons. We call the method getContentPane to get the content pane and assign it to a new container object. We instantiate a new flowLayout object and set it with setLayout. And we set the initial location and size of the applet with setLocation and setSize. And we're adding the components. Now let's look at the steps that we need to follow in order to implement ActionListener in this project. First, we need to import the package Java AWT Event. Second, we need to implement ActionListener. Third, we need to add ActionListener to each component. In this case, there are three buttons that if we click, we wish to handle the event. So phasers, and then photon torpedoes and quantum torpedoes. So we're adding ActionListener to all of them. And finally, fourth, we have to add the event handler method. And for ActionListener, that's actionPerformed. So we're going to use the function getSource, and once we get source, we can then detect which component or which button was clicked, and we're going to display some text that's different according to each button, firing phasers, firing photon torpedoes, or firing quantum torpedoes. To actually see how ActionListener works, we'll examine it in different kinds of code. This first method is the old school way of implementing ActionListener, in which case first we would import the Java AWT event package. Second, we would implement ActionListener. Third, we would have to add ActionListener to the components we want to listen to. And fourth, we would add a single actionPerform method, and then we would call the function getSource and assign the return value to an object, and then we could just use if statements, and if it evaluates to or equals that object, we can do different things based on which button was clicked. So if I were to run this project here, let me close this and bring this up. I'll run it alongside the actionPerform method so you can see. So I'm listening on B phasers, BP torpedoes, and BQ torpedoes. Well, what happens if I click B phasers? Then it changes the JLabel text to firing phasers. If I click on photon torpedoes, changes it to firing photon torpedoes because that was detected after getSource. And finally, if I click on quantum torpedoes, that gets detected. It says firing quantum torpedoes, all handled within a single actionPerformed event handler method. But I can do different things because I use the function getSource, detect it, and then use if statements to do different things based on which button or component was clicked. In this next example, we're doing something similar to what we did before, but we're going to implement ActionListener in a different way. We have a similar JAPPLET with two JLabels and three JButtons as we did before, but the process is different. First off, notice that we're not having to import Java AWT Event. The only thing we're importing is Java AWT Dimension. Second, notice that at the top of our class specification, we don't have the keyword implements in ActionListener. Well, the very first step, if we do things this way, is we simply add ActionListener to what it is that we want to listen to. So the example is the B phasers button. Once we have the B phasers button, I'm calling add ActionListener. Now, when we do that, nested inside of that as a parameter, dynamically, we're going to build a new ActionListener interface. So we instantiate a new ActionListener interface as an argument, nested inside of the open and closing parentheses of add ActionListener. The third step is that we then create the actionPerformed event handler function, and we override it so that instead of putting code here, we're going to go call our own method, and we'll create our own function for handling that event. Sort of like the way you would use a message map and AFX_message in MSC applications, and then you might write your own method. So again, we override actionPerformed, and we map it to our own function for each component as the third step. And then following the last step is the function that we told it to go call or told it to invoke was B phasers actionPerformed, and then we simply define that to do something. In this case, display the text firing phasers. Once again, here's an example in code. We have two JLabels and three JButtons. Notice we don't have the keyword implements up here in ActionListener. Notice we're not importing the package Java AWT Event. The very first thing we do when we get down here is we add ActionListener to our button bphasers. Once we do that, you can see how Netbeans will highlight it from the opening parenthesis to the closing parenthesis. And in this case, as the parameter, the argument, we're instantiating a whole new ActionListener interface inside of it. Right? So that's in the parentheses. Now, as we instantiate that interface, now we're going to override our own actionPerformed method. And we're going to have it simply go call this method down here, which we later define. And we can put any code in there we like to have it respond to the event when it hears it. So we do that with bphasers. We do that with btorpedoes right here. BP torpedoes, that is, photon torpedoes, and we do it with BQ torpedoes. So I've just put comment tags in between all of them so you can see I'm just doing the same thing. Just another way of doing it. Actually, I kind of prefer the old school method, but this can be very useful when you're doing things like dynamically creating JFrames within a class that pop up and respond to different things, or JMenu objects, things like that. This method can also be very useful in addition to the first. And again, notice down here, this is simply where we've overridden and then mapped it to our own functions to do things, firing phasers, firing photon torpedoes, quantum torpedoes. Just going to do the same thing as the last one. This is a different way that you could code it, and sometimes this way is better, sometimes maybe the previous way is better. It depends on what the job is and how you're trying to apply the code, or in what circumstance you're applying the code. So if we run it, pretty much the same as before. Phaser says firing phasers, photon torpedo says firing photon torpedoes, and quantum torpedo says firing quantum torpedoes. How about using Netbeans Graphical Form Designer? Here's just a third way of essentially doing the same thing. I have created a JAPPLET form so I can use the Graphical Form Designer. And if I were to run the project, it behaves the same. And to code it, all I had to do was drag and drop each component on. In this case, I selected buttons for a J button. And if you look at it, it'll tell you what kind of component it is. It's a J button. I set the properties, and then I simply right-click on the component. I click Events, Action, and Add Action Performed. Once I do that, I can then go down here into the code, and Netbeans already adds the empty event handler method or function for me. And I just type the code in that I want to happen for each event. The next event handling interface we'll examine is KeyListener. KeyListener handles key events in a JFrame or JAPPLET application. If you implement this interface, you must add keyPressed, keyReleased, and keyType methods that take a key event as an argument. You must then call add KeyListener, passing into this pointer on each component you wish to listen to for key events. To summarize, first, import the Java AWT event package. Second, implement the KeyListener interface in the class. Third, add event handler methods keyPressed, keyReleased, and keyTyped. And fourth, add KeyListener with the this pointer on each component to listen to. Note, when using KeyListener in a JFrame or JApplet with components, you must add it to a component that has focus. Simply adding it to the JFrame or JApplet will not work, since they will not receive the focus. Here in this example, we're using a JApplet like we did in the previous examples, and we have some JLabels and a JText field. Now, to implement KeyListener old school, we can't simply add it to the window, like the JFrame or JApplet background. When there are components on a JFrame or JApplet, one of those components will always have the focus instead of the window itself. So it wouldn't be a syntax error if I were to simply add KeyListener to the JFrame or JApplet background, but it would end up being a logic problem because that event would never happen. I would never hear it, I'd never be able to respond to it. So my only choice if I'm going to implement it is I have to put it on some type of component. So in this example, I've created a JText field and called it CatchKeys. And if you look in the code up in the top right corner, I'm calling the function requestFocus to place the focus on our JText field CatchKeys object. When I do that, it'll cause the cursor to blink, and then I add KeyListener, and then I can listen for key events and respond to them. So let's see how we would implement KeyListener old school. First, we import the package Java AWT event. Second, we implement KeyListener. Third, we need to add KeyListener to a component on the JFrame or JApplet and not the window itself. And fourth, we're going to code the event handler function. In this example, I'm using two functions, getKeyCode and getKeyCharacter, just to show you two different ways of pretty much doing the same thing. In getKeyCode, I'm using what's called a VK constant and setting it up or assigning it to the key. VK constants are things like VK enter for enter, VK up, VK down for arrow keys, VKA, VKB. You get the idea. The next function, getKeyCharacter, I'm assigning to a character variable, the char or the character, and it's simply U, D in single quotes, just like you would handle a character. So you can see how those work. Now one more note, even though we're not using them, because these methods are almost like abstract functions in a class, in other words, they're included in the KeyListener interface, we have to include them even though I'm not using them. So they're just empty, but if I left out key released or key typed, it would be a syntax error. The project wouldn't compile. So let's see what this would look like in code. Again, to do it old school style, we're importing the Java AWT event package. Then we're going to implement KeyListener. Here's some JLabels and a JText field because remember, we need some kind of component in our JApplet or JFrame that will request and receive the focus. Then down here, we're going to simply request focus on that object and we're going to add KeyListener to it. And finally, we simply need to code the event handler method or function. And we're using getKeyCode and getKeyCharacter. Remember, getKeyCode returns VK constants like VK enter, up, down, A, B. And then getKeyCharacter will simply return a character. We can handle it either way, just trying to give you some options to choose from. And also, once again, remember, these are like abstract functions. Because they're in the interface, even though I'm not using them, I still have to include them in the code. If I didn't and I were to compile it, it would be a syntax error. So to see how this behaves and how it runs, let's go ahead and run it. And let's resize it a little bit to get our layout manager to kind of resize things there. Alright, so here's our JText field here. You can hardly see it. But it's listening, and the focus has been requested there. So what happens if I hit the U button? You won't be able to see it, but I'm going to press the U button on the keyboard. So it says FTL drive is spinning up. Matter of fact, I'll move this over here so you can also see what's inside the keyPressed event handler method as I do each item. Once I do that, now what happens if I hit the D key? This time I hit D, and then it says FTL drive spinning down. And then what happens if I hit enter? Galactica now jumping. Alright, so again, U, FTL drive is spinning up, D, FTL drive spinning down, and VK enter, Galactica now jumping. So you can see what happens when each of those keys are pressed and the event is handled in key pressed. And you can also see that I couldn't add it directly to the window or JFrame and get a response. I have to add it to some component, and so the component in this example was CatchKeys. As an alternative, you might consider using the EventQueue. If you want to capture global keystrokes, regardless of whether or not a component has focus or what particular JFrame or JApplet interface happens to be displayed, you can make use of the Java EventQueue. This will allow you to capture keystrokes without requiring a component to receive the focus. Here's an example of coding a project that uses the EventQueue instead of implementing the interface KeyListener to catch key events or keystrokes. And again, the advantage of doing it this way is even though you're not using KeyListener, you're able to capture global keystrokes. So you don't have to worry about placing a component on the JFrame or JApplet and then requesting the focus or setting the focus on it, and then worrying about whether or not that component has the focus, because if it doesn't have the focus, then KeyListener won't be able to listen for and handle the events. No, in this example, it doesn't really matter what has to focus. We're going to use the EventQueue, and so it's global. Any key that's pressed or keystroke combination we can catch and handle and do something with. So in the example, if you look on the left, we have a class and it extends JApplet. And this is going to be our interface. Just a normal JApplet interface class, with the exception of we're building an instance of a helper class on our right. So again, if you look at the class on the right, that's our helper class, CatchKeys, and it extends EventQueue. And we have a couple of data members here. If you look down at the bottom, they're private and they're static. They need to be static in this example because we want this to exist as one single instance among all the other classes in our application or in our program. And it's called key. It's a keystroke. And in this case, we also have an instance of the class itself. All right, so public static final CatchKeys and all caps CatchKey, well, that's an instance of the class itself. So it's sort of recursive. Like a recursive function calls itself, this class will build an instance of itself. So let's kind of review the process. First, we need to extend EventQueue. And in doing so, we inherit all of its functions, its methods, and its data members. Second, we're going to override dispatchEvent. DispatchEvent exists in the superclass, or the parent, but we're going to implement our own version, so we're going to override it. Next, we need to capture or get the keystroke event, and we're going to store this. So we catch the keystroke event and we store it in our private data member, or keystroke key. Next, once we do it, we want to convert it to a string. Once we convert it to a string format with the toString method, we can then use the equals method, and then based on whatever key was pressed and the return value, we can do something different. And the way this works, as far as a keystroke, it would say press to U if I press U, press D if I press D, press A if I press A, press enter if I press enter, and so on. So using the toString method and then using equals, I can simply test or detect that and then do something different and handle it based on that key event. Fifth, the next thing we want to do is call the parent's dispatchEvent method to handle any other things that we haven't explicitly handled or overridden in our dispatchEvent method. We're not done yet. The sixth thing we need to do is register a new event in the queue. So we're calling getDefaultToolkit here and getSystemEventQueue and using push. And we're taking our new instance, our sort of recursively built instance of the helper class CatchKeys, and pushing it or inserting it in there. Finally, when we're all done with the helper class and its instances, the very last thing we do, the seventh step, is we need to create an instance of the external class that we created and catch the global keystrokes. And so utilizing this method, again, I can handle or process key events without some of the limitations in KeyListener. So even though this isn't really implementing an event-based interface like we did before, I threw it in here, or I included it in here so you can see another way of doing things if you don't necessarily like the way that KeyListener works. Let's take a look at how this works in code. And remember, for this example, we have to implement two classes. So we have our interface class here, but we have to construct a class that extends the event queue and then do what we want as far as handling the keystroke events in that class. And then we'll just build an instance of it here. So taking a look at our helper class first, remember that we extend event queue. If you look at our data members down here, we have a keystroke, and then we have, in this case, the object itself. Okay, so the name of our class is CatchKeys. Well, here we're building an instance of the class itself. It's recursive, like a function that calls itself. And up here, we have a couple of accessor functions, and they're public, so we can get the instance of CatchKeys, the object that we build or instantiate from it. And also, we want to be able to return the keystroke, so we have getKey here. Now here we're overriding the dispatchEvent method or function from the parent object, the superclass EventQueue. We go inside here, we're going to get the keystroke event, we're going to store it inside of our data member here, key, which is an instance of keystroke. Then we're going to use the method toString to convert that keystroke to a string, and then after we do that, we can use the function equals. And the way it works, or what would be returned if you did a stack trace and were to display this, is pressed U if I hit the U key, or pressed D if I hit the D key, or pressed enter if I hit the enter key. So I can simply use the equals method and match that up against the string, and if it matches that string literal, then here I'm going to say FTL drive spinning up, FTL drive spinning down, or in this case Galactica jumping if I hit the enter key. Then the last thing I want to do is I want to remember to turn around and then call the parent class or superclass's dispatchEvent method in case there's anything left undone. So now with our helper class defined, again, if we go to our interface that extends JAPPLET, this is just a normal JAPPLET with the exception that we're going to build an instance of our CatchKeys helper class object. And we're going to call the method getInstance. When we do that, remember that in this case this is our public accessor function or method, and it returns CatchKey. And CatchKey is sort of our recursive instance, or statically recursive instance of the class itself. So it'll sit there kind of hovering up there in memory, listening for global key events regardless of whatever component might have the focus on this JAPPLET. So let's see how it works. We're going to run it. And in this example, notice that there's no JText field. We don't need it. We don't need any component to get the focus because this is global. So if I hit U, notice it says FTL drive spinning up. If I hit D, FTL drive spinning down. If I hit enter, it says Galactica jumping. And it does that because it's globally listening for the events here. You kind of scroll up a little bit. And each time I get that key combination, and then I test for it, and I meet the condition, it's going to simply change the, status or the text of our JLabel. And also I had to make this public and static because since I'm in a class that's outside of my class here, I had to make the JLabel public and static to get at it. But again, watch the behavior. I'm going to press the U key, FTL drive spinning up. I'm going to press the D key, FTL drive spinning down. I'm going to press the Enter key, Galactica jumping. So that's using the EventQueue to catch global keystrokes and process global key events. Now the previous method will catch one key press at a time. But what if we want to use the EventQueue to catch combinations of keystrokes? Like when you do Control Alt and a key, or Control and a key, or Alt and a key. Now in this next example, I couldn't fit all the code in a single slide. So it's broken up into 2 slides. And the first slide we're going to look at is the helper class object, CatchKeys. Or actually in this example, CatchKeys 2, because it's our second version and we're extending the functionality of the original CatchKeys. Like its predecessor, it extends EventQueue. And it has many of the same features, but you'll also notice some key differences here in the code. First, we have a string here called combo key. And it gets keystrokes and checks for combo keys or key combinations. Okay, so you just want to make sure that it's a valid key combination, that it's not null. We don't want to unnecessarily process events that we don't have to. Here we're going to get the action, whatever the action was. And then we're simply going to call the event handler method, and in this case it'll be an overridden version of actionPerformed. Now the next little bit of action happens in the interface class, the one that extends JAPPLET. So here in this class we have specified or set up some events, and we've added some items to our JAPPLET interface or application. And this is actually where the action happens for the actionPerformed event. Okay, so in this case we have to define the keystroke combination to be used as a shortcut or combo key. And so the first combo key combination will be the combination of Control and Alt and S to activate the self-destruct on the Galactica. Once I do that, then I have to define the action. So I define the action to be performed when the combo key defined above occurs. In this case, what will happen? I'm simply going to display self-destruct activated in a JOption pane, a little pop-up window. Once again, to see how this new example works in code, here is our helper class. Alright, so our new and improved version of CatchKeys called CatchKeys 2. And it has some of the same data members as before, but you'll also notice a few new data members in here and some methods or functions as well. So in this case, an input map and an action map. Same accessor methods as before, but we also have 2 new public accessors to get the input map and the action map. Okay, and then also in addition, notice that there are just a few issues here or changes down here. In this case, our string to get the combo key, and then here we're calling the get method on combo key if it's not null, and basically the actionPerformed, the combo action. Also down here, once again we're taking our recursive instance of the class and pushing it into the system EventQueue. So with our new helper class set up, let's see how the interface class changed as well. We still have to build an instance of our CatchKeys class object like we did before, and we still have to call the method getInstance to return an instance to it. And then in addition, here are some other things that we're doing as far as calling the public accessor functions. And we're getting, in this case, self-destruct and self-destruct for the input map and action map, and abort self-destruct and abort self-destruct via our accessor functions. And then now we need to actually define, in this case, the key combination. So the combination of Control and Alt and S, if we press those key combinations, it's going to fire off a JOption pane, self-destruct activated. Combination of Control, Alt, and A is going to fire off self-destruct aborted. And the combination in this case of just Control and P without the Alt, and that's going to plot hyperspace coordinates for Galactica. Again, another JOption pane. So let's see how that works with both the keystroke definitions and the actionPerform function or method being defined in the interface class. So if we were to run this example, As before, if you look at the helper class, we're still handling U, D, and enter. And I'll illustrate that. I'm going to hit the U key. FTL drive spinning up, I'll hit the D key. FTL drive spinning down, I'll hit enter. Galactica jumping. But in addition to what we did previously, now we also have these shortcut key combinations, okay, available to us. And to illustrate that, the very first one here, we'll look at Control and Alt and S. In this case, self-destruct activated. Control Alt A, self-destruct aborted, and then finally Control P, plotting hyperspace coordinates for Galactica. The next event handling interface we're going to examine is MouseListener. MouseListener handles mouse events in a JFrame or JAPPLET application. If you implement this interface, you must add mouse pressed, mouse released, mouse entered, mouse exited, and mouse clicked methods that take a mouse event as an argument. You must then call add MouseListener and pass them to this pointer on each component you wish to listen to for mouse events. To summarize, first, import the Java AWT event package. Second, implement the MouseListener interface and the class. Third, add the event handler methods mouse pressed, mouse released, mouse entered, mouse exited, and mouse clicked. You must add them all even if you don't use them all. Fourth, call add MouseListener, passing them to this pointer on each component you wish to listen to. Here's an example of implementing MouseListener. Now, normally in a situation like this, I'd use JButtons and I'd implement ActionListener, and I would handle the events inside of actionPerformed. But here, instead of JButtons, I'm going to add JLabels, and I'm going to draw a border around them, and we're going to implement MouseListener. And inside the mouse pressed event handler method, I'm just going to get the X and Y coordinates of where I click the mouse. And if I click the mouse inside of one of the JLabel frames, where the border is or in the box, just detecting X and Y with multiple if statements, I'm going to do different things. So let's take a look at the step-by-step process. First, I need to import the package Java AWT event. Second, I need to implement MouseListener. Third, I need to add MouseListener, in this case to the JAPPLET or window background itself. Fourth, I need to code the mouse pressed event handler method. And you can see I have getX and getY to get the X and Y coordinates, and multiple if statements to handle different labels that I click on based on the range of the X and Y coordinates. Finally, note that even though I'm not using them, I have to or I must include the event handler methods mouse released, mouse entered, mouse exited, and mouse clicked. Again, to see how this works in code, notice the packages I'm importing, swing AWT and AWT event. I'm extending JAPPLET with my class hyperdrive console, and I'm implementing MouseListener. Instead of JButtons, I have these JLabels, and then once I get the content pane and set the layout manager, I add them to the JAPPLET. Then I'm going to go call configure components, which will simply set properties on them, the color, and then create a border around each of my JLabels. Finally, I'm adding MouseListener to the window background or the JAPPLET background. Then inside of mouse pressed, I'm calling getX and getY to get the X and Y coordinate every time a mouse event is triggered. So exactly wherever my mouse is touching or the arrow is pointing, the X and Y coordinate will be returned as a mouse event. So I can get that with getX and getY, and then down here in these if statements, I'm simply going to do different things based on whether or not I click within the range of X and Y coordinates for each of those JLabels. And to figure this out, I just added a JOption pane into the mouse press method where it would give me the XY coordinates. So it provided me a quick and easy way to get the numerical range of X and Y just going across and going down. And I've commented it out, but if I needed to add more JLabels, then I could simply uncomment that, and that would give me an easy way to get the X and Y coordinates again. And again, down here, notice these are the empty methods. I'm not using them, but I have to add them because I'm implementing, in this example, MouseListener. So if I were to run it, let's see what happens if I run the application. I'm going to run it here, and notice now when I click on any of these boxes, if I'm within the range, notice that in this case, system is on standby for the JLabel, but it's going to change. So if I click on plot course, plotting course for Falcon, jump into hyperspace, Millennium Falcon jumping, exit hyperspace, Falcon exiting hyperspace, hyperdrive on, and hyperdrive off, hyperdrive off. Alright, so any of those, as long as it falls within the mouse coordinates of the border of that JLabel, then it's triggering the event. Alright. Now if I were to click outside of those coordinates, those XY coordinates, notice nothing happens. And that's how the event is triggered and processed when I implement MouseListener and I handle it with mouse pressed. The last event handling interface we're going to examine is Runnable. There are many more, but in the interest of keeping this video from becoming longer than it already is, we're going to stop here. Runnable handles thread events in a JFrame or JAPPLET application. If you implement this interface, you must add the run method to handle thread events. You do not have to call any add_listener method like we have done when implementing previous interfaces, but you may need to create or start a thread or threaded process. To summarize, first, import the Java AWT event package. Second, implement the runnable interface in the class. And third, code the required run event handler method. In this example of a threaded process, I'm creating an arcade game called Poly Battlefield. It extends applet and it implements the interface runnable. Because of that, I have to import the Java AWT event package to get at it. And remember, if I implement runnable, I have to code the required run function or handler. So let's get onto the run method and see what happens here. Here we have a thread object, and we're getting the current thread. The applet itself runs in a threaded process. So when we have main game loop, then we're going to, in this case, call polygon master update, and several animations and update functions and methods will be called. And we're going to repaint the screen. And then there's some more decision code down here. While it is the main game loop, while it's not, in this case, we're going to go through and detect for things like enemy fire and whether or not it's an enemy attack window or game's over, things that we'll cover later in other examples. But more importantly, let's take a look at the thread and how it's used with run when we implement the runnable interface. So up here in our globals, I'm declaring public and static our thread main game thread. And let's go look at the start method down here. Okay, so now that we have our global thread object, I'm instantiating it, and when I do, I pass on to this pointer. So this thread represents the JApplet interface, applet interface itself. Okay, and then also I have another thread, an enemy attack window. These are multiple threads that will run side by side in a multi-threaded process. Now, in this case, I'm giving main game loop a priority of 1, and I'm calling the start method on the thread. And once I do that, then all of the code and things that are inside the run method will also be processed. And then finally, if and only if enemy fire, which is a boolean, is set to be true, I'm also going to go ahead and set the priority and start the enemy attack window thread as well. So let's see how that works when we run it. Alright, and in this case, this is the threaded process that I'm on. And in this case, I can hit the menu, and if I want to, let's say we'll modify the background color somewhat. And it's an applet, so it can be embedded on a web page. But you can see how the multi-threaded processes work as they run side by side or simultaneously, because we're implementing the runnable interface and the required run event handler method. Here's another example of a multi-threaded process in a game, but in this example I'm using a swing worker thread. And I have to do this in a multi-threaded fashion because if I didn't, when I'm doing things like pausing or sleeping, if everything was in the same thread, it would lock up the interface and the player wouldn't be able to interact with the interface. So what I have to do is I'm going to implement or use a swing worker thread object. And let me pull up the navigator pane here. And what happens is they go into a method called combat, and they engage in combat, and it does several things. The first thing it does is it's going to build a swing worker object and then implement the abstract functions inside the swing worker class. Okay, so it's going to set up what happens when the thread starts and when it finishes. It's going to go through here, and in addition to enabling attack buttons and stopping theme music and instead starting fight song music or looping that, and it's going to launch or build a new opponent frame. A JFrame will pop up that shows the opponent. It's going to create a battlefield, which is sort of a little polygon arcade game JFrame that pops up, which just gives you an extra 100 points in your defense if you're able to take your pixels and connect with the enemy. Okay, so it does that. And then it finally comes down here and it's going to go ahead and call battle sequence, which will pass on opponent 1 and opponent 2, the player, and the person they're engaged in combat with. And finally, when it's done, it'll say who won and give us some feedback information, and then enable and disable the appropriate buttons. So anyway, within combat, once I have defined the swing worker class object, I'm going to start the swing worker class object, banana start, just as I would a normal thread object. And finally, that battle sequence method or function that it's calling is down here. And this is why I have to launch it inside of a swing worker or a separate thread, because when I call this function wait, it's actually sleeping on that particular part of the battle sequence. And I don't want to lock up the interface. I want to make sure that the player can still interact with the game even while a part of a game process or a thread is having pause or sleep called on it. And that's all that method does right there. So you can see why I need a multi-threaded process in the game. And again, to see how that looks, so I'm going to go ahead and open the splash screen, and we'll launch the main JFrame from the JApplet, and click Start. And I have KeyListener here. So in this case, the JText file has the focus, and I can just hit Enter if I want. And I'll do a destroyer, and let's see. And let's see, allocate points here, and ready to play. Good to continue, so now we're in player start. And I have a cheat here, which I'll need probably to illustrate some of the other features. So I'm going to go down here to stop 1, and look at a tilde. Free appearance gives you godlike powers. Cheat, okay, yeah. Pretty bad when you don't know your own cheat. Alright, let me select the key. Go here, and here we're going to launch a multi-threaded process. So the interface is in one thread. Over here, in this defense pane, alright, defense successful. But you can see that here's the battle sequence and the combat loop that's running right here in this text area. And because it's a multi-threaded process, I can still do other things. The interface isn't locked. If it weren't for that swing worker thread, though, I wouldn't be able to click on any of these objects on the interface. It'd be locked until the loop was, complete. Not what I want. I want the player to be able to choose different weapons and do things. So in this case, I can choose the Glock. I can choose the grenade. I can defend. Try to use inventory items. Let's see. If I come over here, let's do a med kit. And I'll use a couple of med kits. Increase my health some. And then same thing here. Boy, attack window really sucks. Okay, so in this case I defeated the opponent, but it was only because of that swing worker and that combat loop and battle sequence being a multi-threaded process that I could still interact with the interface while it was pausing and sleeping during those different parts of the battle sequence. It's just another use of a threaded object. Just a note on Runnable and Run. Many Java, JFrame, and JAPPLET applications use classes that extend the base Java thread class. Sometimes these customized Runnable objects may be used with the interface Runnable and their Run method. Sometimes they are not, and the Start method is called on them from a constructor or some other place in the project's class hierarchy. Threading is a voluminous and lengthy topic, so we will save its details for another time.